All right, ideal gases. What's the difference between a normal gas and the ideal gas? And what do we call a real gas versus an ideal gas? These are all the terms that we're going to be talking about. But by now, you should know at least what a gas means. And comparing it to a liquid and solid, this is an example for oxygen. A gas has small molecules that are very, very apart from each other, and they have a high motion compared to liquids and solids, right? But I'll tell you in this video more qualities that make a gas, and we'll talk about what an ideal gas is. So gases are very important, and we use them a lot in chemistry as well. And as you know, we're breathing gas right now. You know, we move around not thinking about gases a lot, but we are breathing them every second, right? So gases are really important in science. We also pay so much attention about gases, the qualities of gases, and the reactions between gases and gases and solids and so on and so forth. So let's talk about what an ideal gas is. So after looking at a bunch of gases, after doing a lot of experiments, scientists found that a lot of gas molecules behave very, very similarly. So when it comes to how they react to temperature, to volume, to pressure, and even their mass or amount, they behave very, very similarly at a microscopic level. And from there, scientists made like a model gas, like an example of a gas by averaging all those experiments. And that's how they came up with an idea of, well, ideal gas, an ideal gas. Just like you would, take 1,000 people and say, oh, what's an example of an ideal person? Well, an ideal person probably breathes oxygen and does all these things. So that's pretty much how they came up with an ideal gas. Now, we can measure different things. In this chapter, we're going to look at temperature, volume, pressure, and mass. And we can measure these and compare how they behave in different gases. And that's how we define ideal gases, and that's how we can look at their differences. And we're going to look at a few of these. But before we do that, let's look at what the scientists agreed upon when it came to ideal gases. So I'm going to look at things that we call kinetic molecular theory of gases. So this is a theory that talks about how these gases behave generally. Right? So the kinetic molecular theory of gases, and whenever you see kinetic, think of movement and energy that results into that movement. So the first theory says that the gases are made up of small atoms, and these are in constant random motion. These are always moving, right? So the gases, as you see on this figure on the left here, are in constant random motion. That's number one. Number two, the distance of separation is really, really large that we pretty much ignore it. And we say that gas is mostly empty space. Number three, all gas particles behave independently, meaning that there are no attractive or repulsive forces between them. But again, this is just a generalization. In reality, some gases have some attractive forces between them, but this is the ideal gas law. Number four, gas particles will collide with each other and the walls of the container without losing energy. Now, again, there is energy involved, but the energy will be transferred from one atom to another, so the whole system is not going to lose energy. And number five, the average energy, the average motion energy will increase if you increase the temperature. Those are the four rules of the kinetic molecular theory of gases. And using these four rules, we can explain some of the behavior that we see in gases. For example, gases are easily compressible compared to liquids and solids, and this is because the gases is mostly empty space, right? Another one is gases will expand to fill any available volume. Well, why? It's because they move freely without energy and they don't have any attractive forces, so they can move anywhere you put them. All right. Another one is gas have really low density. Why? Because they are mostly empty spaces, empty space. Gas can diffuse easily through each other, and this is because they are in continuous motion, right? And they can just go through with each other because they are mostly empty space, right? The gas exert pressure on their containers, yes, because of the collisions of the gases. And lastly, the gas will behave most ideally. So all these things that we just mentioned will happen mostly whenever you have low pressure and high temperature, right? Because when you have a high temperature, uh, we don't have a lot of attractive forces and you have really rapid motion. And whenever you have low pressure, you have a really large distance between them, right? So the gases will behave this way whenever you have low pressure and high temperature. All right. So a few other things we can talk about your ideal gas. The molar volume talks about how if you have a normotypical ideal gas, 1 mole of it will occupy 22.4 liters at standard temperature and pressure. What standard temperature and pressure? 0 degrees Celsius, 1 atmosphere. So at 1 atmosphere and 0 degrees Celsius, 1 mole of a gas, of a typical ideal gas, will occupy 22.4 liters. And we call this the molar volume. Another thing that I really want to talk about is remember that ideal gases are different from real gases. Very important. This is just a model that we're using, but in reality, a gas will behave differently, right? And we talked about how an ideal gas will behave that way mostly when you have low pressure and high temperature, but also non-polar gases will behave more ideally than polar gases because if you remember in our attractive forces, non-polar gas molecules don't have so much attraction, whereas if you have a polar molecule, it will attract to another polar molecule, right? But remember that ideal gases are different from real gases, even though it's a useful generalization. Another thing that I want to talk about is that you can look at the number of moles, the volume, the temperature, the pressure. You can change these, and these change in relation to each other. And there are gas laws that will give you the relations. And we talk about gas laws in another video, but just know that this change. And a lot of these are very intuitive. Like if you heat up water and it will give you vapor, will it want to increase or decrease volume? You want to increase the volume, right? That's why your lid pops off when you heat up water. Is because the gas wants to expand as you increase temperature. So when you increase temperature, the volume increases. That's an example. Pressure is the one that confuses people. Pressure is force per unit area, right? So the pressure is what the force that a gas is pushing per a certain area. That is the pressure. Let me give you an example. So this link that I included here will take you to a website where you can play with some of these. So this website right here is a simulation of how a gas behaves. So if we use a pump to pump some molecules of gas here, first of all, as you increase the amount, you'll see that the pressure reading here will increase. The more you add, the higher the pressure. Why? Because now the molecules, you increase amount of them, but they have a smaller surface, so they're going to bump into each other more, and you're increasing the pressure. So when you increase the number of moles, the pressure is increasing, right? You can also heat up, increase the temperature. If you increase the temperature, the pressure is going to increase as well. All right, they're going to bump into each other way more, right? So that's another thing you can do. Let's also change the volume. You can change the volume. So let's increase the volume here. If you increase the volume, the pressure is going to decrease, right? Increase the volume, the pressure decreases because now they have a bigger volume to move around, right? If you cool down, the pressure decreases and so on and so forth. So this is how an ideal gas behaves. And we're going to learn more about the formulas that govern these laws, right? Because you can mathematically calculate the change in temperature, for example, when you change the pressure and so on and so forth. So we'll talk more about that in another video, but that is enough. And now you know what a gas means, what an ideal gas means, and the difference between an ideal and a real gas. I'll see you next.